Behind me is a huge tank which stores millions of gallons of liquefied natural gas, energy that will be available for future use, most likely in the winter months. How did it get here? Well, contrary to what many people think, rarely does a regional company own gas produced by a natural gas well.
Across North America, natural gas is transported over 300,000 miles of pipelines. Let's see how this vast system works. Unrefined natural gas retrieved from the gas wells is processed to remove water and other impurities. So processed natural gas is ready to be moved through the underground highways. Large steel pipes, sometimes as much as 4 feet in diameter, called transmission lines, are owned and operated by various companies. And the natural gas they move travels under very high pressure, over 1,000 pounds per square inch. Every 50 to 60 miles, compressor stations boost the pressure. In general, this is necessary to keep it moving quickly through the system, since friction inside the pipe slows it down. Transmission lines travel through areas which are set apart from other construction activities and services. They're called right-of-way corridors.
The local gas companies tap into the transmission lines at centers called gate or border stations. Here, 2 things happen. The odor-producing chemicals are added, and gas pressure is reduced before being delivered through the local distribution lines. These lines are called mains, ranging in size between 2 and 20 inches in diameter. They're transporting the gas at pressures generally under 100 pounds per square inch. Substantially less than transmission lines, but, as you can hear, still powerful.
From these distribution lines, natural gas is channeled to factories, businesses, and homes.
The mains are almost always underground, ideally at least 2 feet down and sometimes further. But gas pipe can also be seen above ground, along bridges and over water. As a responder, there are many kinds of piping materials you may encounter in emergencies. Originally, gas mains were made of wood, then cast iron, and around the turn of the 20th century, steel was introduced. But now, the most typical materials are coated steel and plastic. While larger pipes generally mean higher pressure, the actual amount of gas pressure or load inside the pipe can vary greatly. The utility company regulates pressures. And a large pipe can have a low pressure at a given time, and likewise, a smaller pipe can have a higher pressure. Before reaching its final destination, the natural gas pressure is further reduced at various regulator stations throughout the system. This is a typical in-ground regulator installation. Gas flows in this direction. A regulator controls the pressure of the gas moving through the pipes. There are inlet valves on one side and outlet valves on the other.
Overpressurization, while rare, is extremely hazardous. That's why safety devices, called relief valves, are incorporated in the system. They operate somewhat like teapot kettles, only here instead of steam, they vent gas which is overpressurized in the system. With relief valves, you never want to attempt adjusting or shutting off the escaping gas, because it's doing its job. Shutting a relief valve can cause a whole other set of dangerous conditions. So let the relief valves vent, and make sure the utility company is aware of this and can take the necessary corrective measures with this equipment. In general, the gas utilized by industry has a higher pressure and volume, requiring larger regulators and meters, especially if manufacturing is involved.
Residential regulators are much smaller, and at this point, the gas, which was originally pressurized at over 1,000 pounds per square inch, is now reduced to only 1/4 pound per square inch.
Keep in mind, while most meters are located outside, others are in the structure. And if there is a leak, a water pipe may look the same as a gas pipe. So in most cases, the best way to make sure it's a gas pipe is to trace it back to the meter. In emergency situations, if at all possible, cutting off the gas supply at this point, the meter valve, is the most effective way to resolve a dangerous situation. When the valve stem is in line with the gas piping, it's open. When it's across the piping, it's closed. To shut the supply off, a quarter turn of the valve either way is all it takes, with a tool such as a crescent wrench. The meter valve controls the flow of gas at this point in the system, so turning it off interrupts the fuel source. And when turned off, it should be secured by being tied, labeled as such, and left off until the utility company arrives. Let's review some of the key concepts in this section of the program. True or false? The local utility company controls the transmission pipeline. False.
Generally,
Transmission lines are managed by interstate pipeline companies, not the local distribution company. A regulator controls gas pressure at which point? The gate station, the main, a house. Regulators control pressure at all points through the utility's distribution system. When overpressurization happens in a gas line, what type of valve comes into play? Relief valves protect against overpressurization and need to be left alone to do their job.